Hi everyone, it's Miss Marion. So we are starting Unit 3. If you don't have a workbook, then you'll need to make sure you get one. And so you can get one from me or from the office, but make sure you have them. Let's turn to page 133 in your workbook, and let's give yourself a sentence of how you feel about. I can graph a proportional relationship from a story, and I can use a constant of proportionality to compare the pace of different animals. And we're actually going to do lesson 1 and lesson 2 today. So in a second, we're going to do lesson 2's I can statements. Also on page 133, here is lesson 2's I can statements also. I can graph a proportional relationship from an equation. And I can tell when two graphs are of the same proportional relationship, even if the scales are different. And so go ahead and write yourself a sentence about how you feel about these two I can statements, and then also number. So 1, I don't get it. 2, I kind of get it. 3, I got it. And then 4, I can teach it to myself. And you should have a number also for lesson 1's I can statements too. So we're going to go ahead and turn to page 7, but before you actually start this lesson, you will need the Unit 2, Lesson 2, Card Sort Proportional Relationships page. It's actually on the top of the Canvas page. You'll actually need that because we're going to be working with that also. So make sure you get that printed out or you open up and you look at it. Okay. But on page 7, we have this. And what I want you to do is to write one sentence of what you notice and then one sentence of what you wonder. So go ahead and pause at this time. So what we can, a couple of things we can say as far as we notice. I noticed that one of the graphs has 2 lines, the other one has 1. I noticed that the scales are the same, so meaning like the numbers on the bottom are the same. Numbers going up and down are also the same. I noticed that these 2 lines are labeled. This one is not. What I wonder is, okay, what are we doing with this? Why are we working with 2 graphs? What are we going to go ahead and do with these? So let's go ahead and let's look at page 8. And on page 8, we have both of the graph, and then we also have this kind of bug chart kind of thing. And it says a ladybug and ant move at a constant speed. The diagrams with tick marks show their positions at different times. Each tick mark represents 1 centimeter. So we need to remember that we have the 1 centimeter kind of stuff going on, okay? And on page 8, what we're asked to do is we lines U and V show the position of the 2 bugs. Which line shows the ladybug's movement and which one shows the ant's movement? And then how long does it take the ladybug to travel 12 centimeters? And then also the ant. So we're just going to do these 2 questions right now on page 8. I know there's more of them, but let's go ahead and just focus on these. So go ahead and pause and label the 2. So as we can kind of see, we have it that, so the ladybug, she is on line U. So this is ladybug. And then the ant is line V. And you can kind of pull it from where it is. So this is where the ladybug starts, right? That's 1, 2, 3. So at 2 seconds, she's gone 3. So we can kind of look at it. So like 1, 2, 3. And then 1 here kind of thing, right? And so just kind of like comparing the 2, the ladybug is the first one, line V, and then the ant is line V. And then the second question was, how long does it take for the ladybugs to travel 12 centimeter and then the ant to do 12 centimeters also? So if we, how much is that? So the ladybug, it takes 6 seconds. And the ant takes 4 seconds. Okay, and we can kind of pull that from as far as following the system, as far as what the ant and the ladybug are doing, from like this is 6, and then going from there. So moving on, still on page 8, we're going to go ahead and answer the question. So scale the vertical and horizontal axis by labeling each grid line with a number You will need to use the time and distance information shown in the tick mark diagram. So we're going to be going ahead and using this information up here, and then we're going to be labeling it here. Mark and label the point on line U and a point on line V that represents the time and position for each bug after traveling 1 centimeter. Okay, so go ahead and pause again, go ahead and work through that right now, and then we'll see what we get as far as our answers. All right, as you can see, I went ahead and labeled my graph, and on the bottom it says distance traveled. Distance traveled are all these little tick marks here. And then if you look at the vertical axis, you notice that it says that it's this time that we have on there. So, and that the time I got from here, so we went 0, 2, 4, and then 6 along with it. So here I have it labeled, okay? And then I pulled the information from our tick mark kind of situation, and then I went ahead and put it on our graph. It says mark and label the point where line U and point V that represents the position after the 1 centimeter itself. So we're going to go ahead and we're going to look at that. So if we have it as 1 centimeter, and we're looking at that 1 centimeter itself, we want to go ahead and we want to look at, let's do a different color. Let's do red. So we're looking at this point here, and we're looking at this point here. So we can actually look at, so the top one is going to be 1, 1/2. And then the bottom one, so then the bottom one is going to be 1, 1/3. So now let's look at the Are You Ready for More? It's on page 9. We're still kind of on the same page, and we're looking at the ladybug and the ant, and then also the graph. How fast is each bug traveling? And then will there ever be a time when the purple bug, the ant, is twice as far away from the start as the red bug, the ladybug? Explain your reasoning. So go ahead and pause right now and answer those questions. So let's look at it. Let's go ahead and first let's look at the ladybug. Okay, so the ladybug at 2 seconds. So that ladybug at 2 seconds again is 1, 2, 3, 4, because we're looking at the front part of the face. So at 2 seconds, the ladybug is at 4. So if we want to go ahead and write that down, we can say, well, let's do ladybug in red. So at 2 seconds, right, the ladybug is 4 centimeters, right? But we want to go ahead and kind of simplify this down. So we can do it as she's going 2 centimeters per 1 second. And then let's look at the ant. Let's do the ant in blue. So the ant is 1. So it's 1, 2, 3, 4, 5, 6. Okay, so at 2 seconds, the ladybug is 6. So we have it as, so it's 6 centimeters for 2 seconds. And we want to reduce that down, so it's 3 centimeters for 1 second. So this is the rate that they are traveling. So ladybug is 2 centimeters per 1 second. The ant is 3 centimeters for 1 second. Will the ant ever be twice as far as the ladybug? And the answer is no, because the ant is always half as much, again, as far away from the ladybug, and so it's just never ever going to end up being twice as much. All right, let's go ahead and look at page 9, the moving twice as fast. So so it says refer to the tick mark diagram, so same diagram and graph that we've been working with. And imagine a bug that is moving twice as fast. So let's go ahead and let's underline that. So twice as fast as the ladybugs. On each tick mark diagram, mark the position of the bug and then plot the positions on the coordinate axis so put it on the graph, right? And then connect them together, and then that will make a third line. So go ahead and pause right now and figure out where that went. And we're going to call this one a spider. So it's Halloween. Let's call it a spider. All right, here is, well, they have a different bug, but I think it should be a spider. So as you notice, we have this extra bug kind of going along here. And then if we took those and we put it on to remember its distance and then its time, if we plotted it along, it would be this kind of yellowish line, okay? And this is twice as fast as the ladybug, which is the V1. So what we want to do is we want to go from here and we want to write an equation for each of the lines. And the way that we do that is, remember, we are using a constant rate of change or a proportional rate. So we did that on Friday. We're talking about proportional relationships. And remember, when we have the proportional relationship kind of stuff, we are looking at the y equals kx. And this was in 7th grade. The k is that proportional relationship, and it's pretty much the unit rate on these. So go ahead, pause right now, and find the equations for the ladybug, the ant, and then the extra bug, which we call the spider. All right, so let's go ahead and let's find that out. So let's put the ladybug in red. So what was the rate of change, that unit rate of change? Remember, we did that a couple, actually on page 8, we found that. So the ladybug is the y equals 1 over 2x. And so it's because remember, when we're finding this k, it's going to be our vertical over our horizontal. And so we can actually do that with a slope triangle, just like we've been doing it in the last unit. So I told you this is not going away. So we have it as the 2 over 4. Okay, so 2 over 4, we're reduced down to 1 over 2. Let's go ahead and do the ant. So again, let's find a slope triangle. And I'm going to show a different one just so we can kind of, that's the ladybug. We need to actually do, there it is. We need to do the ant. That's this one. So we can follow that line. Okay, so we have 2 over 6. So we have the fraction of 2 over 6. That reduces down to 1 over 3. So the ant's line is y equals 1 over 3x. And then we're going to do the spider. Spider is that third one. And then we can go ahead and do slope triangle. Again, you can put your slope triangle anywhere you want. I'm just doing it here so we can kind of see them. So we have it as 2, and then the bottom part is 8. So we have 2 over 8. That reduces down to 1 over 4. So the spider's equation is 1 over 4x. So as you can see, we can actually write equations with these lines, with the slope triangles. We can look at those different things and notice how on here that 1 comma 1/2, that was the constant rate of change. And then the 1 1/3, that was also that constant rate of change. And we can also find this through slope triangles as far as writing the equation themselves. So now we're going into lesson 2. On page 16 on lesson 2, it says, here's a graph that represents a variety of different situations. Write an equation for the graph, so kind of just what we did, and then sketch the new graph of this relationship on the graph that they actually gave us. So go ahead and pause for a second and go ahead and try that. All right, let's go ahead and go over it. Let's find our equation for this. So again, let's go ahead and let's do a slope triangle. So we have, let's do it in blue. Right? And so how far is our vertical going up and down? That is 14. How far is our horizontal going side to side? That is 8. So our slope, remember our slope is our vertical over horizontal, is 14 over 8. And we're going to reduce down to 7 over 4. And remember that we want to keep this as an improper fraction. The reason why it kind of helps us with that, the slope triangle itself. And so we're going to go ahead and we're actually going to apply it to this graph here. There's a couple of things that we can go ahead and do. First of all, let's write the equation. Sorry, let's go ahead and put that together. So our equation is going to be y equals 7 over 4x is our equation itself. The easiest way to go ahead and plot a new line is we can actually do a table. So a t-table, right? We have an x and then we have a y. And then what we can do is we can pull these numbers here that we have. So notice how this is a different scale than we have as before. So remember in science we talk about scales on graphs. Well, this is kind of show how it's a little bit different. So let's grab our calculator. And the first number that we're going to go ahead and put in is we're going to put in 20, okay? So then we're going to say 7 over 4 times 20, okay? Put it in your calculator, press enter, and let's figure that out what that is. All right, so 7 over 4 times 20 is 35. So our first point that we're going to go ahead and put in is 20, 35. So 20, 35, okay? Let's put a point there. So we're going to put a point right there. Next one, let's go ahead and let's put in 40. So let's do 40, 7 over 4 times, not 20. We're doing 40. Okay, so 7 over 4 times 40, that is 70. So we have 40, 70. Let's do one more for kicks and giggles. So let's go ahead and put 60 in there. So 7 under 4, 60. Okay, 7 over 4, 60. And we have it as 105. So we have this line kind of going this way. So notice the lines are a little bit different as far as in the graph, and that's because of the scale, okay? So the x-axis and the y-axis, but they actually go ahead and they represent exactly the same equation, the y equals 7 over 4x. All right, this is actually from the paper that is on the top part of this lessons page, and we're going to go through these. And what we're going to do is we are going to, again, we're going to find the equation for work card A, B, C, and then I and J, and then I'm going to show you what we're actually going to go ahead and do, okay? So go ahead and take a second, so pause for a second, and let's find the equation for all of these cards. All right, now since you have found the equation, let's go ahead and figure out if we have done it correctly. So again, let's go ahead and do our slope triangle. So we have here, right? So we want our vertical and then our horizontal. So what's our vertical? Our vertical is 6, horizontal is 24. So 6 over 24. Let's put that in our calculator. Let's reduce it down because fractions always want to be skinny no matter what. Okay, let's reduce that down. That reduces down to 1 over 4. So this one is y equals 1 over 4x. Card B is 6 over 2. So we have vertical, horizontal. Reduce it down, and we're going to have 3. So this equation is y equals 3x. Card C, again, we're going to do our slope triangle. And all of these equations work this way because see how this line goes to the 0, 0. If the line goes through 0, 0, and this is from last year, 7th grade, this is called a proportional equation, proportional relationship, and it goes through 0, 0. This is the only time we can do it this way. Later on, we're going to do a little bit different. Okay, but again, we're going to find our vertical and our horizontal. So see how that's 150, and so it goes through it. So the vertical for this one is going to be 175. Horizontal is going to be 50. So we're going to have it as vertical, horizontal. Again, let's go ahead and let's put that in as a fraction. Simplify it down. What does it simplify down to? Okay, so We want this as a improper fraction, not a mixed one, okay? So this actually simplifies down to 7 over 2. So the equation is y equals 7 over 2x, okay? Let's go to I, okay? What are we looking for as far as the I? So we want our vertical again. Our horizontal, okay? So that's 300. That's 400. So we have 400, 300. So it's going to be 4 over 3. So this equation is y equals 4 over 3x. And then last one, we have it as 0.5, 0.2. So 0.5 is the 5/10. 0.2 is 2/10. So we're going to have 5/10 divide 2/10. Okay, so let's do 5/10 divided by 2/10. Put it in your calculator, press enter. Again, we want it simplified and we want it as an improper fraction because it helps us later. So it's going to be 5 over 2. So this equation is y equals 5 over 2x. Okay, so I'm going to circle all of these and I'll explain to you why we need to know all of this. So we have this one, this one, this one, this one, and this one. Okay, so the rest of the worksheet that we have is you're finding the equations for the rest of them, and the rest of them should be one of these 5 equations. And we're actually we're going to kind of put them together, but you're going to use the so you're going to fill out the rest of the worksheet, write the equations for them, and then once you're done with it, we're going to tape it in on page 19 in your workbook. So go ahead and pause right now and find the rest of the equations for the worksheet. All right, here's the equations for the rest of the worksheets as far as the different cards on there. So go ahead and pause, and then you can correct your worksheet. Make sure you're doing it correctly because we're writing equations for lines is what we're trying to do for this part of the lesson for today. This is actually lesson 2. Now that you have paused it, we can actually see again, we can write these equations. We can find that it's called a proportional relationship. And a proportional relationship, remember, it always goes through 0, 0. And then we can make our slope triangle just like we've been doing. And then that actually makes the equation itself. So because remember, it's y equal kx. And that's what, it's the constant rate of proportionality. And that's what you did in 7th grade. And so we're kind of just applying it here in 8th grade. And then we're going to apply it even more later on this unit and then also next unit. So again, we're able to write the equations because we have this constant, we have that k, the constant rate of proportionality. And so that's what we were looking at for today. All right, let's go ahead and turn back to page 133. This is for lesson 1. This is the first part of our lesson for today. And we're going to write a second sentence and a number. So I can graph a proportional relationship from a story. I can use a constant of proportionality to compare the pace of different animals. So that was all the ant and the ladybug and then eventually the spider kind of stuff. Write yourself a sentence and a number. So 1, I don't understand. 2, I kind of got it. 3, I did get it. But then 4, I can teach it to my friend. This is the second part of our lesson. This is actually lesson 2 in our workbook. So I can graph a proportional relationship from an equation. I can tell when 2 graphs are of the same proportionality relationship, even if the scales are different. And then again, you're going to write yourself a sentence about how you feel about these, and then a number. So 1, I don't understand. 2, I kind of got it. 3, I did get it. And then 4, I can teach it to my friend. So this is our lesson for today. Make sure you go ahead and do both practice problems. Yes, we have 2 of them, okay? But you're going to do both practice problems, and then those can be found in the modules, and then also on the lessons, okay? Have a good day. Thank you. Bye.